ketones, which enter the brain metabolism system through another route than glucose, could bypass blocks to glucose utilization and then be used by the brain to do its work. And the possibility was opened up that this might be a helpful treatment.
So was that part of your research, determining how the ketones were metabolized by the brain cells?
Well, we first, of course, looked at the biochemistry of it, and we noticed that the ketones enter the brain and into the brain cells by a mechanism that transports glucose into brain cells. So it was immediately apparent that if there's a block to glucose, then ketones might bypass that block, and the ketones would then be used where the brain was starving. It would begin to get nourishment again, and that would get the sick cells to work better and prevent further damage to the nervous system. So I started getting interested in finding out whether a ketone-generating diet would be helpful for patients with Parkinson's disease. And so we got a little bit of money from a grant and studied it in 7 patients. 2 of them dropped out before we really had a chance to study them. So we studied 5 patients with Parkinson's disease.
And I'm sorry, Ted, at that point, how were you raising their ketone levels?
We were using a very high fat, very low carbohydrate, controlled protein diet.
Okay. Is that what's called the ketogenic diet now, or a version of it?
Yeah, it's what I would call the classic ketogenic diet, the one that's been used for many years to treat children with drug-resistant epilepsy. So we recruited 5 people, studied them in the neurological division of the Beth Israel Hospital in New York, which was affiliated with our hospital.